Hello and welcome to, what are we called again? Paradox Computing! Yes, welcome back to some Paradox Computing videos. So we're here at my Tower of Evil. Ha ha ha! Well, it almost looks like a face of some sort, doesn't it? It's fucking strange. Anyway, so, welcome back. Welcome back. So, this episode, we're going to clean up a few little bits and pieces. Going to show you just a couple of little changes and some stuff. But, first off, alright, well, let's point out another obvious security hole in our program. So right here we've got the password program. As you can see, this has been displaying every time we use the door. It's been showing what the password is and, you know, who's been telling us it's okay to open the door and everything, and what the message is, and it's just not cool. So, we are going to do something about that. What we are going to do is... here we have reconnected our disk drive to this computer, which is opening this door. And we're going to, in the disk, we are going to edit... what we call this again? Lock client. Lock client. Here we are. So, the change we need to make is just here at the bottom. I've already put it in. It's adding a term.clear, which will clear the screen, and set the cursor position, which will put the cursor back up to the top left-hand corner of the screen. It'll get rid of everything, so that will solve all of our problems regarding that. So, of course, what am I doing? So, that's good. So we will save that. We've already saved that. So really what we need to do now is, and this is another lesson in commands and stuff, we need to delete. So it's a lock client. Delete lock client. So ls, that should be gone now. Yep. And now we need to copy... copy from disk. Okay. Wow. It's got something on my mind, obviously. Copy from disk, and lock client, yeah, to, just a little lock, client here on the drive. So that should do it, ls. Yep, there you go. So lock client's now, the new and improved lock client is now on here. So our server is up and running. So let's run lock. But one thing that will make it hang is if I don't attach a modem to the back of it. So yeah, now it's got a modem. So we'll go lock client. So that's going to that should straight away turn on the... Yeah, so the modem's now got that red line there. So the modem's on, and it's looking for our password. So we put the right password in, which is still ASDF. Welcome! That's opened the door for us. And then, when that shuts, after 6 seconds, yep, here we go. And this is now no longer displaying our password. So we can just come and go as we please. So we're going to have to drop the disk drive pretty much on all of them and upgrade them all so they all stop doing that. But yes, to be honest, there might be a few little tweaks to the program I want to do before I go around and do that to all of them. Now though, if we come upstairs, so you can see though, we've got the program running on all of them, they've all got their thing, they're all asking for the what's but this is out of date and it's still displaying all this stuff, which we really don't want people to know, so just putting the clear in there's the easiest thing. We don't even have to delete those other lines. Now here's where something's a bit different. Look at this. What the fuck's going on here? What is this madness? Why can I hear zombies? I get the feeling I have to go beat something to death. Don't need those covers. Let's see. That's not up here. They're all on top of this roof. Wow. No. No. Unless they're in here. Let's see how they could be in there. So we've got a new door here. That's asking for a password. But password's not ASDF. What's going on? Nothing's happening. Well, this is basically what we've got there is our server, and now that server's got the passwords to all the other computers, so we want to keep that safe. So set up a different computer. So this one's got another password. That's 1234. And that now lets us into our secure room, which is going to have all our computer servers. So we're probably going to have, you know, some different things, maybe some turtles running off of one over here. That can be our play around bench. We'll have a lot of stuff going on. Now, if you notice, that door hasn't shut, and there's no modem on it. This is running a completely local program. So I kind of threw straight into the deep end of going with you know, the RedNet, you know, servers and everything. You don't have to do that. You don't have to do that. Plus, also, I left this one to made it wait for us to type in close. And then the door will shut. So that's nice. So there's no time delay or anything, because I figure, you know, might want to leave this open. If I'm running upstairs, I don't want to have to, you know, come back down here and type in the password all over again. That password is going to change, by the way. So that's just going to stay open for us. Okay, so how did we do this? Well, I haven't backed up the program on this. As you all know, I have issues with pressing Control T. But anyway, this has actually got so you can't press Control T anyway. And I haven't saved the program. Actually, well, you know, it took me a few minutes to write that program. I haven't saved that program anywhere. So if I did this, I'd lose the program. Correct? Not correct. This computer, you might notice, has a number at the end of it. It's saved its computer tag. If I run back in here, I can go ls. Oh, look at that. There's a program I made. How did that happen? This is very, very useful. So you don't have to run, you know, always be backing up all your stuff on disks and everything. You can type set. Sorry, you don't type set at all. You type label set, and then you can call it Diddy Dumb. Oh, it probably has to be one word, but yeah. There we go. So now this computer is now set to, its name is Diddy Dumb. Though I don't, yeah. Or if you just hit nothing, there you go. It's been removed. But we're gonna call it inner door. Inner door. That's what you want. Inner door. So this is great. This also works with mining turtles. Yeah. So you can put a program on a mining turtle, dig it up, and then place it somewhere else. Still have the program on it. You don't have to put a disk drive next to it and load the program or anything. It's a freaking godsend. Use that command. Use it. Anyway, so we also want to see, we're just going to edit this little password. So this is how you could create, you know, just, you know, something that doesn't check in with a server. It's just an easy to use local password. So here we go. So we're saying door to equal open. Now, if door equals closed, then, okay, so I know this looks a little bit backwards, but it's because we're on a loop. I'll explain this top bit here after we do after we go through down here. So let's just pretend we start here, okay? So the program is saying write, so it's putting that up on the screen, password, and we're going to make password actually equal whatever the user puts in. Now, if password equals that 1234, so if what they put in was 1234. Then, and notice though we've got, it's a string. They're not actual number values, so it's not 1234. It's a string of 1234. So whenever you do an IO read, it's going to be a string, not like a number value. You can, if I needed it to be a number value, and I know we talked about strings earlier, so this is probably a good time to clarify that, because you know, I don't think I made a lot of sense when I was trying to talk back then. But say we actually wanted it to be the number value of 1234, because say we wanted the say this was like a turtle and we wanted it to actually go 1234 spaces, and it's not going to be able to get that number off a string. So we need to go, we'd say it would be pass, so this is off topic, but why not? We'll do it now anyway. Password equals to number I think. Yeah, is that right? Is there a dot in there? I think it's the number 1, 2, 3, 4. Yeah. Um, and you probably do that actually on the other side of this, and then we could maybe test that. Sounds like the sun's coming up. Sorry, you guys have to listen to all these zombies. Then I mean we could just well, actually if we just delete that, this might not work. So just bear with me. But we'll just do our little numbers and strings demonstration. So we're just gonna now say 1, 2, 3. So password is equal to number password. So that's what we're setting to. Yeah. So password is now going to be equal to a number, and then we can say if password is equal to 1234, then so that should work. And if it doesn't, well then I guess we'll find out. I don't think it's 2 dot number. I think it's just, or is it 2 dot number? I guess we'll find out. It doesn't look 2 number like that doesn't look right to me. So I don't know. Let's find out. Password is okay, and 1, 2, 3, 4. There you go. So that's an example of yeah, of that. So that's strings and numbers. Yeah. And like, number values. Oh, did that just disappear? Did I pick it up? No, I picked it up. Thank God. Okay. Good. Cool. So let's go back into edit password. So we come down and where were we at? So we've made this to a number instead of a string, just because we could. But anyway, so if password is equal to 1, 2, 3, 4, it's going to redstone set output on the left. So it's on the left of the computer, which is our left, not the computer's left. And that's how it's going to activate the door. Then it's going to write welcome, type close to close the door. Now if I put close in in inverted commas, it would actually put whatever close is currently the value of. So yeah, it was going to have to put it like that. There is ways around it. I think you put a slash in front of it or something, but forget about it. This will do for now. Okay, and then so we do it. We set door to equal a value of IORead. Now if it's not equal to yeah, that's where things kind of went a bit squiffy. There is supposed to be an else statement of print denied, basically. So if it's not equal to 1, 2, 3, 4, go to the else and print denied. Thing is, we've got this term.clear and term set cursor position directly underneath it, so it's not going to print denied. I probably should clean that up, or I kind of just don't care that it's not printing that. To be honest, it wouldn't be too much of a fix, but yeah, the easiest thing is actually just get rid of that, and we'll end our little statement. Yeah, oops. Yeah, so let's end that. Okay, and then it clears that. So, door, if you see the last thing on the statement is door is now equal to IORead. And what we're looking for here is we've told the user to type close to close the door. So what we've actually then got up here is up the top, that bit that we skipped before. So by default, we're putting door is equal to open. But if door is equal to close in a string, because it'll be the input, then go ahead and turn the left output to false. So turn off the redstone output on the left. And again, it's not going to get that statement though, unless it's already gone through the whole loop. Like the redstone wouldn't be on unless it's gone through the whole loop already once. So yeah, so you kind of have the loop here at the top to deal with something down the bottom. If that makes sense, I hope that makes sense. So that first if statement, the first time it runs through this loop, obviously it's going to skip this because door is, as you can see here, door is set to open, and this is asking it to be closed. And it's not going to, and as you see, we've got the while true do. Did I say, yeah, while true do, which is an infinite loop. If you didn't see my earlier videos, while true do is just an infinite loop. It'll just keep looping over and over and over. So it's going to go from, while true do to this last end. It's just going to loop everything here on the screen. And so at the end here, we ask the user type close, which is going to set door to close because they typed close. So when it comes back around the loop and come up to the top, if door is equal to close, then it's going to turn off that redstone output, which we put on by putting in the password. Anyway, so thanks for watching, guys.